All right. And so today we are going to talk about how we can make timers in processing and how we can use that to run code that only runs after a certain amount of time has passed. And so, what are timers and how are they useful? Well, there are times in making our programs, especially if we think maybe we want to start making, simple little video games and things like that in processing. There may be times where we don't want our code just to be automatically running all the time. We may want certain things to wait for a certain amount of time before it's being run. And so, an example is like, let's say you made like a traffic light animation, right? Where after every 10 seconds, you want to change which light is on. Well, to do that, you need to know when 10 seconds have passed. And when it has passed, that's when you would change whichever circle you have kind of colored up or whatever in your little traffic light animation. Or let's say you're making Pong, right? And you make it where the ball starts in the middle of the screen and then it moves towards one of the players. You maybe don't want the ball to move right away because maybe the players aren't ready. Maybe you want to wait just 3 seconds. There's a little countdown or something. And then after 3 seconds, the ball is let loose and the game starts. But to do that, you need to know, how, when has 3 seconds passed? And once it's passed, that's when you start running the code. So how do we make that work in processing? And so that's what we're going to talk about today. And so the first thing we need to talk about is this millis function. So it's written just like this in processing, but the millis function can be used to make timers. And we're going to talk about this a bunch today. Whenever you call this function, whenever you run millis, you call millis, it records the amount of milliseconds that have occurred since the program first started. And so the reason it's milliseconds is because the program runs so fast. It tries to do 30 frames per second, right? That's pretty fast. And so it records how much time has passed since the whole program started, when you press the play button in milliseconds. Now, that being said, so if the program's been going for 10 milliseconds and we run this will give us the value of 10. If it's been running for 1 second, that's 1,000 milliseconds. It will give us that value back. And so what we can kind of think of this as a timestamp. So whenever you call the millis function, it's almost like recording a timestamp of how much time has passed since the beginning of the program. So we can start using this as a timekeeper. And I like to think of it as whenever you call millis, it's like pressing a button on a stopwatch. And so we're going to build on that analogy here in a second. But just to show you what it looks like in code, don't worry about what all this is. We'll go through this example in detail later on. But if you want to make something equal to millis, the amount of time that's passed, you would just say, you have a variable here. It's just an int right now called startTime. You just say my variable is equal to millis. This makes startTime equal to the amount of time that's passed since the program started. And so actually, I'm going to comment all this out. We'll talk again about this in more detail later. But if we look at this, what does my code do? Well, I say startTime is equal to millis. Ignore that doesn't matter. And I just print out the value of startTime. And this is in my setup. So setup is run first thing in my program, right? And so if it's running first thing in my program, then that means it's pretty close to the beginning of the program, right? So this value should be pretty small. But let's just check it out. If I press play here, you'll see start time is 127. So from the time that I pressed play to the time that it ran, this line of code here was 127 milliseconds. And that makes sense because that's a very small amount of time. It's, just over 1/10 of a second. But what's kind of cool, if I press play again, it's almost definitely going to be different. 144, so it took a little bit longer if I press play again. A little bit shorter. And so, your computer, depending on what other things it's doing, and even the temperature of the CPU and, things like that, is going to give you a different value here. But it should always be kind of close because it's here in this setup. And so you can see all this does, it tells us the amount of time that's passed since the beginning of the program. Now, that being said, we can think of this as being like us recording a timestamp or pressing a button on a stopwatch. And so before we continue on with that analogy, how does a stopwatch work? Well, there's a start button. So whenever you press the start button, if it's not currently running, it starts counting the amount of time that's passed. So it starts off at 0. When you press it, this counter starts going up. I'm sure y'all have seen a stopwatch before, right? So then it'll say like, oh, seconds passed, 2 seconds passed, 3 seconds, blah, blah, blah. There's also this lap button. So while the timer is running, the stopwatch is running, if you press this lap button, it records the amount of time that's passed since when you first press the start button, right? So you press the start button, it starts the timer, it starts counting. The lap button then says, hey, how much time has passed since when this stopwatch was started? And it gives you that value back. So if I press the start button and then, after it's lapped, maybe 5 seconds, if I press it, it's going to tell me 5 seconds have passed. If I press the start button again while it's currently running, it also resets the counter back to 0, so it resets the timer. It turns out, so you're probably familiar with how this works, but we can actually copy the same structure using millis in processing. So let's talk about how we do that. Well, so using millis, the first thing we should do, in fact, you've already gotten a glimpse of this in that example that I showed, but what we should always do is we make a variable. I usually call it start time. You can call it whatever you want. There's nothing magical about the name start time, but I always use that for my timer names. But I make a variable called start time. And then in my setup function, I set it equal to millis. This is the same thing as me pressing the start button on my stopwatch. So it's the same as this step right here. Whenever I say start time is equal to millis in my setup, that's me starting the countdown. You'll see why here in a bit. But just keep that in mind. When I say start time is equal to millis in the setup, it's the same as me starting my stopwatch when I press the start button. Now, again, whenever you use millis, whenever you call it, you can use it as a timestamp, because what does it do? It gives you the amount of time that's passed since when you press the play button, when you first started the program. Okay. Well, now I have another variable here. Instead of start time, I'm going to call it end time. And so, same thing though, I'm going to set it equal to millis, so it's also going to be equal to a timestamp. The difference here, though, is instead of calling it in my setup, which is run once at the beginning, I'm going to call it in my draw function. Now, the function this is going to play for us is this is going to be like me pressing the lap button on my stopwatch. So here, when I said start time equal to millis in the setup, that's like me pressing the start button on my stopwatch. Then saying end time equals millis in my draw, that's like me pressing the lap button. Okay? So just keep that in mind. It'll make more sense as we go. Then what we can start doing, usually also in your draw, you say, okay, what's the difference between end time and start time? What is end time minus start time? What's the difference between these two? First off, take a moment and think about, what does this represent conceptually? What is end time minus start time here? Well, what we can think about is these are both timestamps, right? Because start time is a timestamp that was declared in our setup. End time is a timestamp that was declared every time draw runs. So if we say end time minus start time, all that is telling us is the amount of time that has passed since when end time got its value and start time got its value. So it's an interval of time between when this was called and between when this was called. So the difference between those gives us that time difference. Okay. This is like giving us that lap value. Because what does a stopwatch do? Well, whenever you press the start button, it starts counting. And then you press the lap button, it tells you, okay, how much time has passed between when you press the lap button and when you press the start button. That's exactly what this expression gives us. Because end time, that's like us pressing the lap button. Start time's like us pressing the start button. So saying what's the difference between those? Well, it tells us the amount of time that has passed between us pressing the lap button and pressing the start button. Or in other words, pressing or setting end time equals to millis and start time equals to millis. It's just like a stopwatch. So hopefully that makes sense. So how do we use this time difference, though? Because remember, a few minutes ago, I was talking about what we want to do is do something like if we make Pong, we want it to wait 3 seconds before we start the program actually running, before we make the players and the ball move and everything. So we want to have time play into an effect our program so that things only happen when, after 5 seconds have passed or something like that. And so that's what we want to make happen. And we can actually use this end time minus start time, this time difference, to get this to work for us. Because if you imagine, now that we can detect how much time has passed which we can now with end time minus start time, all we have to do is say, hey, if the time passed, if that's greater than 5 seconds, let's say, run our code that makes the ball move, right? Or, if end time minus start time, if that's greater than 10 seconds, let's say, change the animation of my stoplight. So now instead of the red circle being real bright, make the green circle real bright. Something like that. So all we have to do is say, hey, if end time minus start time is greater than some interval of time, do some code, right? Make a block of code, basically. So how do we do that? Well, first we need another variable. So we have start time and end time already. Let's have a third variable. It's just going to be a constant, though. It's not going to be really a timestamp. It's going to be an interval of time. And for my example here, I have interval equals 1,000. Remember, we're dealing in milliseconds here. So how long is 1,000 milliseconds? Well, that's just 1 second, right? So if I have an interval equals to 1,000, then that's like me saying, hey, I have an interval of 1 second. If you want an interval of 10 seconds, it would be 10,000. You just take whatever you want in seconds and multiply it by 1,000. Okay. What we can do is once we have this variable, which is just a constant, this won't change or anything. But once we have this, we can compare this variable to end time minus start time. Remember, end time minus start time is the time difference. It's like our stopwatch. It's the amount of time that has passed from when we started our timer and pressed the lap button. Okay, so what we can do is we can just make an if statement, basically. We can say, hey, check to see if the time, if end time minus start time, if that time interval, if that is greater than or equal to interval, our interval variable, then do something. So this makes events happen once every time that amount of time has passed. And so let me actually bring up a picture of that. So if we look at this, you can see that what I can do is make an if statement around this principle, right? So if end time minus start time, the time difference between pressing the start button and the lap button, if that amount of time that's passed, if that's greater than or equal to my interval variable, which remember is equal to some amount of time, right? Like 1,000 in this case, or you make it 10,000 for 10 seconds or whatever. But if the amount of time that's passed, if that's a greater than or equal to interval, do some code, right? Do whatever you want. Do whatever you want, ever since, after you've reached this interval, basically, right? So in the Pong example, if we want to make it where the ball moves after 5 seconds, what you can say is, hey, make this interval 5,000 for 5 seconds. If this amount of time right here, if that time difference is greater than or equal to 5,000, make the circle move, right? Add some speed or whatever to the circle. If it's the stoplight animation thing, you would just change the color of each of the circles or whatever, right? Now, also notice this bit right here, though. You should always have this at the end of your if statement. So I always call this if statement, this is my timer code, right? So whenever I say the timer is triggered, what code do I run? I look in this block of code right here. But whenever the timer is triggered, the last thing you want to do is reset your stopwatch. How do you do that? Well, if we think about a stopwatch, what you would do is you would press the start button again, and that starts the counter back at 0. That's what this line of code does. Remember, we called this originally in the setup. Once at the beginning of the program, we said, hey, make start time equals to millis, which means start the timer from scratch. We're now going to call that again here at the end of their timer. So whenever our timer triggers once, if we want it to keep going every 10 seconds or something, like the stoplight animation, where it changes color, every 10 seconds or whatever. Well, to make it do that every 10 seconds, we need to reset the stopwatch so it starts counting from 0 again, and then it'll start counting up. Once it reaches over 10 seconds, this runs again and goes on from there. So hopefully that makes sense. I do have some slides here that goes over this whole workflow, just to review it for you, and then I'll bring up an actual example in code, and we can take a look at it. And so the workflow for making timers is the first thing is I usually make an interval variable. It's a constant variable. It's not going to change at any point usually. The units are in milliseconds because whenever we're dealing with time with computers, it's usually milliseconds. That's just how fast it goes. But this interval is going to be the amount of time that needs to pass before the code that we want to run with our timer should be triggered. So in the stoplight example, it was 10 seconds because you don't want it to change colors except for every 10 seconds. So interval would be set equal to 10,000, which is the value of milliseconds, which is equal to 10 seconds. So first thing is you make the interval variable. Then you make a start time variable. You can make it equal to an int or a long. And this is initialized in your setup function. So whenever you first make this, right, in your setup function, you then say start time is equal to millis. That's like you taking your stopwatch and pressing that start button. So it's going to start that stopwatch. It's going to start that counter. Then in our draw, we need to have end time. So end time should be declared just up above in your global variables with all your other variables. But this should be set equal to millis in our draw. The reason is because draw is going to run about 30 times a second, right? And so it needs to check to see, how much time has passed, how much time has passed, how much time has passed. So you do that by comparing end time to start time, but you need to always be constantly updating your end time value. So how do we do that? Well, we set end time equals to millis, and we make sure to do that in our draw function so that in every frame that processing runs, it updates the value of end time. And remember, this is the same, it does the same thing as pressing the lap button on our stopwatch. What we can then do is once we have this, we can compare end time to start time. We can say, okay, what's the time difference between end time and start time? If that time difference, so in other words, what's the time difference between pressing the start button on our stopwatch and the lap button? If the time difference there, if that is greater than our interval value, then we're going to start running the code that we want to run whenever this timer is supposed to trigger. And how do we do that? Well, we do that with an if statement. So you have like if, end time on a start time is greater than or equal to your interval. Then you run whatever code you want to run, whenever the timer is triggered. And then we always need to reset our start time at the end of that block of code by setting back equals to millis. That's like us pressing start button again on our stopwatch, which resets the timer to go back to the beginning. If you don't reset your start time like that, then what's going to happen is that once your timer triggers once, it's going to trigger every frame after that. And that's not usually what you want. There may be some applications where you want that to happen, but that's not usually what you want to happen. So you should usually reset your start time by setting it back equal to millis. And so that's the general workflow. Let me bring up my example again. We'll actually look at some code and kind of think through this together. Okay, so what do I have here? Well, I have my start time variable, end time interval. I just declare them up above. These, where all my global variables are. So not in my setup or my draw, because they're going to be used all throughout my program, right? So they're declared up here in my global space. In my setup, I just made a window size. In this case, it doesn't really matter. But then I initialized my start time by setting it equal to millis. This is me clicking the start button on my stopwatch. In fact, I'm not even going to add a comment. Press the start button on my stopwatch. It's just an analogy. There's not actually a stopwatch thing going on in processing, but I think it's a very useful analogy. Then I need to set my interval. I need to initialize it. I have it equal to 1 second in this case. So interval, I'm going to add a comment here, just because comments are useful. Setting, or amount of time that needs to pass before the timer is triggered. We'll save that. Okay, then what I'm going to do as well, I'm going to just print out the start time at the beginning. Then in my draw, just like we talked about before, I have my end time. I'm going to set it equals to millis, which is the same as pressing the lap button on my stopwatch. And again, there's no magical stopwatch in processing, but I like the analogy, and so it's useful for us to think about it in this way. I should also point out that I am using the variable start time, the variable end time, and the variable interval. I called them these things. There's nothing magical, though, about these names. If you want to call this Tom and Janet and, Bobby Boy 5000, some crazy, weird, silly names, you can. There's nothing magical about me using start time and end time and interval. That being said, I do use them because these names kind of make sense for what they're doing. And so, I just made this joke. Tom, Janet, and Bobby Boy 5000. You could make these names, right? But what's bad about this is that if I read Bobby Boy 5000, I have no idea what that means. So if I'm trying to understand what the code is, it's not very helpful to me. And so that's why I always call mine start time, end time, and interval, just because those names make sense for what they're doing. But anyways, back to this workflow, right? So in draw, I set end time equals to millis. That's like me pressing the lap button. What I'm also going to do is print out the value of end time. I also have this if statement here, but we'll talk about that in a second. Let's just press play here, and let's look at what's printed out. Press play. Then I'm going to stop it real quick. All right. I'm going to go up to the top. You see it said start time is equal to 189. Cool. That prints only once. And that makes sense because if we think about it, that's only called here in my setup function, right? That's run once at the beginning, so I only see that code once. Then in my draw, if I go back to the top, if I just follow it in order, the first thing it did, it says end time is equal to 205. Well, that makes sense because start time, if that's 189, then when it calls end time here, that's 205 milliseconds, so that's a little bit more time that has passed since the beginning of our program. Because remember, millis, all millis does by itself is it gives us the amount of milliseconds that have passed since the beginning of the program. So this is said, okay, when this bit of code was run, 189 milliseconds have passed. When this has been run during the first frame of draw, 205 milliseconds have passed. But draw doesn't just run once, of course, it runs over and over and over again. So once it reached the end, it started back over in draw, ran this line of code again. At that time, it was equal to 222 milliseconds. It keeps doing that, 238, 255. It keeps on going. You see it'll go on until forever, with end time becoming bigger and bigger and bigger and bigger over time. Okay, so that's kind of how that works, right? Because it's in draw, end time is going to get bigger and bigger over time because the amount of time that's passed since when we press the play button is getting bigger and bigger over time. But now, if we put this if statement back, this is kind of our timer code. So this, so check to see if timer is triggered. And then inside this if statement, the block of code inside of this, so these two lines right here, this is code to run whenever the timer has triggered. Okay, so if we think about this, whenever end time minus start time is greater than or equal to interval, print out this. Print line, the sentence, timer triggered, yay, and then reset our stopwatch. So we want to add a comment to that, reset our stopwatch. Boom. Okay, and so now let's press play again, and let's see when do we see this sentence here. So if we press play, then I'm going to stop it real quick. Okay, yeah, so we did get something there. So start time was 187. That was, this line right here, line 14. Then it started calling our draw, which meant it set end time equal to millis every frame that it ran. So end time was 203, 218, 235, it kept going. Remember, our start time was 187. Once we got to our end time being 1202, which is over 1,000 milliseconds bigger than our start time, it then said, hey, timer triggered, yay. It printed out our sentence. So that's because our end time was equal to 1202, and our start time was equal to, I think, 187? 187, right. 187. So the difference between these was 1,000 or more. And remember, our interval value here, if we go back, was 1,000. So the difference between end time and start time was greater than 1,000. So this if statement was true, so then it came into this if statement, it printed out our sentence here, and then it reset the stopwatch by saying start time is equal to millis again. So hopefully that makes sense. I'm going to press play again and let it run a few seconds so we can see that this timer is going to run and this sentence is going to be printed out every second that's passed once we start our program. I'll let it run a couple seconds. Okay, that's good. Click stop. And so let's see, can I go back to my start time? Is that too early? Yeah, so 184. So that means at around 1,184, we should see this printed out. So let's see. So end time is 1,000. Yeah, okay, here. And then it says timer triggered. Yay, great. Then start time is reset. In fact, even to show this, I'm actually going to even take this and print that out right here as well. So that whenever we reset our start time, we're going to see what the new start time value is. So I'm going to press play on that. Let's let it run for a few seconds. La-di-la. Click stop. Go back up. Our start time is 191. So around 1,191. It should be triggered. 1,190. Yeah, 1206. Timer triggered. Yay. And then reset start time to be 1206. So that means around 2206, this should happen again. So let's check. Around 2206. 2207, which is just over 1,000. It happened again. It reset start time to be 2207. No time had passed between that. It was so quick. So around 3207, something should happen again. Let's check that. 32. So right when it got over that, timer is triggered. Yay. It's going to keep going on until forever. So what you can do with that is you can have it change the colors of a circle, or you can have it make the ball start moving in Pong, or do whatever you want inside of this if statement. And so hopefully that makes sense to you. And so my challenge to you to practice this is to make something where it's very easy. I just want you to draw a sketch with 2 circles, and then I want you to flip the colors of these circles whenever the timer is triggered. And so to make this happen, you, of course, need to have a timer, so start time, end time, and all that good stuff. But you also will probably use some Booleans, right? So you'll check the value of a Boolean, and based off whatever the Boolean value is, you'll change the color of the circle. So that's my little mini challenge for you to practice with this. And so hopefully this has been helpful to you. Hopefully this all makes sense. And thank you so much for your time. I will see you next time.